Randomness is inherent in nature. In common parlance, randomness is the apparent or actual lack of pattern. It lacks predictability in events. Randomness is exhibited when the next state of process cannot be exactly determined from the previous state. It involves uncertainty. We hear a lot about random motion, indeterminacy, chance mutations, and so on. No matter how advanced our technology becomes, there would be inherent theoretical uncertainty in any real world phenomenon. Whether a couple would give birth to a male child or a female child is random. Winning of a lottery amount by a person is random. Public transportation disruptions, failure of electronic part in a system, getting stuck by lightning, being killed in a train accident or road accident, getting income tax return verified by the income tax department, and so on, are the examples of the events happening randomly. Though many people believe that everything that occurs is a result of causality, the chain of causes and effects, and there is nothing like randomness in nature. They believe that some of phenomena are so complex that they go beyond our understanding, and so in such cases randomness appears. In this sense, one may say that randomness is illusion. In such cases, an outcome seems random to us, but that is only because of our insufficient understanding of science and nature. In 1902, Carl Pearson, who is known as the father of statistics, did some experiment on a roulette wheel to test the randomness of runs. To a great surprise, he discovered, with a high degree of statistical significance, that the runs so obtained were not purely random. What? The roulette wheel was not random. Professor Pearson was greatly surprised at this discovery. But this result in itself tells us nothing. We know that there is no such thing as a pure random draw, for the outcome of the draw somewhere depends upon the quality of the equipment. With enough minute inspection, one would be able to uncover the non-randomness somewhere. For example, the wheel itself may not have been perfectly balanced, or perhaps the spinning ball was not completely spherical. Whether the randomness is real or it is just illusion, it hardly matters. In both cases, patterns of variation are not known. Statistics tries to find out some regularity in randomness, some system in unsystematic happenings, and some order in disorders. It makes attempts to search for some patterns and to find explanation for that. How difficult it is to imagine a pattern which emerges from randomness. The pattern certainly exhibits the kind of structure and lawfulness in nature. Statistics attempts to describe patterns of variability that data may display. It searches for some probabilistic law according to which variation in data takes place. Probabilistic modeling is a statistical technique used to take into account the impact of random events on causes in predicting the potential occurrence of future outcomes. It is a convenient way to describe the distribution of the outcomes of a trial or an experiment. Obviously, it requires wisdom, deep insight in the behavior of the events that are changing. In the words of Burnham Anderson, modeling is an art as well as a science and is directed towards finding a good approximating model as the basis for statistical inference. There are many standard basic probability distributions which help us to know the probabilistic behavior of a random variable and which are widely used for decision making. Binomial, Poisson, negative binomial, geometric, and hypergeometric distributions for discrete random variables, and normal, exponential, Weibull, gamma, and beta distributions for continuous random variables are some important of them. In addition to these, many mathematical models using statistical assumptions are developed. To generate sample data, and to make predictions about the real world. Statistical models are different from mathematical models in the sense that statistical models are non-deterministic. Some important statistical model examples include logistic regression, time series clustering, and decision trees. Thank you.